Welcome back to the video lecture series for Introduction to the Adder Programming using Scala. In this video we're continuing our expression parsing. The last video we started off and we want to be able to write this function here, method called eval, that takes a string that might be something like this. Our previous, we're talking about it with a plus sign in here. And we decided we're going to approach this from a divide and conquer standpoint, which is that we start off by finding the location of the lowest precedence operator. So that's the first half of our function. And then once we've found the lowest precedence operator, assuming one exists, we have to deal with that. And so we wrote this code, which we believe finds the lowest precedence operator at this point. Now I want to write the part where we deal with it. So there's actually two possibilities. One, upload is less than 0. That means there was no lowest precedence operator. Well, what can cause that? There are actually two possibilities here. One is that the string that we got is completely enclosed inside of parentheses. So, for example, if we take this string, it won't find any operator because everything is inside of the parentheses, and we only look at operators that are not inside of parentheses. So I want to say if expr.trim, I want to get rid of any leading and trailing spaces just in case there happen to be some in there. Actually, let's do sub-0 is equal to the character open parentheses. And because we found no operator, we're going to assume that this has trim. There we go. So trim doesn't take any arguments. I need to put a set of parentheses there to signify that is the call to the method. But because it returns to me a string, I can use the sub-0 to get the value out. I had to put the extra set of the open and closed parentheses there, otherwise Scala thinks that I'm trying to pass sub-0 into trim, and it's unhappy with that. So in this case, I want to recursively call eval, and the string that I want to pass it is expr. Once again, I'm going to get rid of any leading and trailing spaces, and then I'm going to take the substring that goes from 1 to expr.length -1. So expr.length -1 is actually the last character. This would be the matching closed parentheses, but substring is exclusive on that end. Else. So what if the whole thing isn't inside of parentheses? Then what's the possibilities for why we didn't find an operator? And the simple answer here is that the number what we got down to, the string, is simply a number. Because as this continues to do the divide and conquer, so first it divides on the plus and we get 4 times 3, and then it will divide on the times and we'll get strings of 4 and 3. And those are just numbers, they don't have operators in them, so this is going to run right through and find no operator, and we just want to take that result and convert it to a double. Okay, what if we did find an operator? Well, then what we need to do depends upon what the operator is. So expr sub oploc match. I have some different cases. Case of a plus. In that situation, I want to recursively call on the two sides and add them. Eval called on substring, called on expr dot substring from 0 to oploc. Remember, it's exclusive on the top, so the fact that this goes to the operator isn't a problem. And I want to add that to eval of expr dot substring from oploc +1, and the version of substring it takes a single argument, goes until the end of the string. The other operator possibilities: minus, multiply, divide, and all we need to change is that. Okay. We could have written this in other ways. It's actually possible to make this less verbose, but that works well enough for us. All of the options there wind up returning something, and there we go. I was able to get rid of the 0.0 at the end. I should finish off by writing a real quick main and figuring out if this actually works. Def main args is an array of strings. Print line eval of that string. Run this and I get 22, which is indeed 12 plus 10. What if I do this? This would be 4 times 5 times 5, which is 100. Bingo, we get 100. Okay, turns out there is a bug in this. The bug occurs when we do something like that. Currently this doesn't handle having negative values very well, because as soon as it sees the negative, it assumes that it's not negative, it's actually subtraction, and I will leave it to my viewers to figure out how you can fix this code to make it so that it will only pick up the minus signs when they're actually subtraction and not when they are negatives. That's it for this video, and we'll see you again later.